Now we're going to translate some trigonometric functions to formulas in X, and we're going to do this with right-angled triangles and the definition of the trigonometric functions in terms of right-angled triangles. And this is it's going to be essential for the method of trigonometric substitution when you're given an integral to calculate in terms of X and you want to translate your answer into x's at the end. Looking for a formula in terms of x for tangent of sine inverse of x, we first draw a right-angled triangle. Remember, sine inverse of x is an angle, so we're going to draw a right-angled triangle with an angle theta in there, which is equal to sine inverse of x. So this means certainly theta is not the right angle, and we must have in our triangle that the opposite over the hypotenuse is x. So the easiest right-angled triangle to draw is one where we have our angle theta here, and the opposite side has length x, and the hypotenuse has length 1. And of course, once we know the length of two sides of this triangle by Pythagoras' theorem, we know the length of the third. It has to be the square root of 1 minus x squared here. Now, from this triangle, we see that tangent of theta, which is sine inverse of x, is equal to the opposite over the adjacent. It's equal to the length of the opposite side, which is x, over the length of the adjacent side, which is the square root of 1 minus x squared. So this gives us an expression for tangent of sine inverse of x in terms of x. Now, of course, this is for an angle between 0 and pi over 2, but all of these formulas are true for other angles.